All right, if you're watching this video, you probably clicked on this video and hopefully you've opened up these notes and also you took a look at these slides, but you don't really need that open, I guess. So obviously you need these notes though. So I'm going to click on these notes. We open it up and voila, here they are. It says right up here, important. Go up to file and then make a copy for the name. Call it your name, plate notes. So what you're going to do is go up to here, go underneath file, go to make a copy, just like that. We're going to call this your name and plate notes. All right, obviously you're not going to be calling it like your name. You're going to put your actual name in there. But for us, that's what's going to work. Good. All right, now it says fill in the blanks and then share with jsor@crec.org. So this button up there, the share button, when you're done, you click this, you put in there JSOAR@crec.org, and then you hit done and it goes sent off to me. All right, and we're going to hit escape there. Awesome. First question, it says, blank blank is the German scientist that noticed all continents seem to fit together like a puzzle. Over here on the slides, it says plate tectonic notes. It says Alfred Wegener, German scientist, noticed in the early 1900s that some continents seem to fit together as a puzzle. Wegener hypothesized that these continents were once a great landmass or supercontinent called Pangaea. So over here, I would be writing Alfred Wegener. All right. He hypothesized that these continents were once a great landmass or supercontinent called Pangaea. I'd be writing that in there. All right, let's read the next slide here. Oh man, we got like a map here. This is Permian. That's 225 million years ago. This is Triassic, 200 million years ago. Jurassic, 135 million years ago. And then Cretaceous, 65 million years ago. And then this right here is present day. Let's see what it wants over here. It says, what's the order of the timeline from oldest to currently Jurassic, present day, Cretaceous, Permian, and Triassic? Hey, if you haven't figured it out yet, this video, you're probably going to need to pause it a few times and just rewind it and rewatch it, and that's okay. So for this, the oldest right here, I'd be putting Permian. The next one, I'd be putting Triassic. The next third one, I'd be putting Jurassic. And then the next one, I'd be putting Cretaceous. And then the last one, I'd be putting present day. And if you need the name for those, they're all right there. Actually, they're all in there too. So we're going to move on. Theory of plate tectonics. Let's see what we got here for that. Theory of plate tectonics. Earth plates are in constant slow motion between 2.5 and 15 centimeters per year. Explains how plates move and form. Since you've been alive, plates have moved more than 180 centimeters. That's about 71 inches or almost 6 feet. Dang, the plates have almost moved the height of me. So let's see what it says over here. Earth's blank are in blank. All right. So it says right here, Earth's plates are in constant slow motion between 2.5 and 15 centimeters per year. Let's see what it says next for the next one. Geologists came to the conclusion in the 1960s that the Earth's lithosphere was broken up into about 12 large pieces called plates that are moving relative to one another. Theory of plate tectonics continued. So over here where it says plates are broken up into about blank large pieces, put 12, all right? Good. And this one says the lithosphere floats upon the asthenosphere, upper mantle. So what I would do is over here, you're going to be having to put the lithosphere floats upon the asthenosphere, upper mantle. If you need those names, they're right there for lithosphere and then asthenosphere. Next slide. Ooh, this one. The lithosphere. Continental plate, granite rock. Oceanic plate, basalts. Then we got ocean and volcanic island, like Hawaii. Continental crust is less dense than oceanic crust. Continental crust is composed of granite. Oceanic crust is composed of basalt. The crust and upper layer of the mantle together make up a zone of rigid, brittle rock called lithosphere. So if we go on over here, it says the blank and blank of the mantle together make up a zone of rigid, brittle rock called so it says the crust and upper layer of the mantle together make up a zone of rigid, brittle rock called the lithosphere. Two types of crust. Continental crust is composed of granite. Continental crust is less dense than oceanic crust. Oceanic crust made up of basalt, more dense than continental crust. Do you think Hartford is sitting on top of granite or basalt? Hey, look, Hartford, Bloomfield, Enfield, all of them, West Hartford, we're sitting on the continental crust, which is probably more granite than basalt. All right. So I'd be putting that one in right around there. I'd be putting granite. Plate movement. Let's see what they got about plate movement. Plate movement. Plate motion is the result of the movement of material in the upper mantle, which drags the overlying plates above. Convection currents take place in the mantle. So for plate movement, result of the movement of material in the mantle? Blank, blank in the mantle moves the plates. All right. Let me redo this one just because I want to make sure I'm not lying to you. All right. Down the upper mantle. Good. Oh, okay. This is result of the movement of the material in the upper mantle, or just mantle, really. All right. Blank, blank is the mantle. In the mantle, move the plates. All right. So let's see what the next one says. Convection currents. The transfer of heat by movements within a fluid. Convection currents within the mantle cause the plates to move. So for this one, convection currents in the mantle move the plates. Heat rises, cool sinks for this, because it says it right here. Hot rises, cool sinks. So, continental drift. The process continues as the current Earth volcano hot spots of the world reflect the edges of the moving plates atop which the continents sit. Do we have that over here? Plate movement known as continental drift. Earthquakes and volcanoes occur at plate boundaries. All right, we're on to stresses, as if this wasn't stressful enough. Oh wait, it says right here, quiz time. All right, it says down here, answers at the bottom of your plate tectonic notes you are filling in. So at the bottom of this page, if you go all the way to the bottom, it'll give you the answers to these. Let's take a look at them now. The plates move along the top of the A, core, B, asthenosphere, C, crust, or D, inner core. I'm not going to give you the answers because they're at the end of your test if you want to take a look. All right, let's take a look at the next quiz. Plate movement occurs because of A, conduction currents in the mantle, B, convection currents in the mantle, C, convection currents in the crust, or D, conduction currents in the crust. And again, answers are at the bottom of your plate tectonics notes. You are filling in at the bottom of these notes. Third question. Earth's lithosphere is broken into a number of large pieces called A, faults, B, volcanoes, C, plates, D, folds. And again, answers are at the bottom of that page. All right, this one says right here, plate boundary wrap. I don't know about that. If you want, give it a play in the notes, okay? Actually, it is pretty good, but let's move on. The 3 types of stress. A force that acts on a rock to change its shape or volume. This is tension, pulls apart, divides. Compression, presses together. And shearing is like when you're rubbing your hands together, or like if you got like your feet kind of just going like this, that's shearing. All right. Let's see what it says over here. Define 3 types in your own words. Oh, shoot. I kind of gave you those. So tension is like pulling apart. Compression is pushing together. And shearing is like rubbing up against something or friction. All right. Oh, wait. Let's see what you got down here. So if you got it right here, the force being used above is, my man is totally shearing right there with his hands. Good. You got a couple of relatives of mine right here. Yeah, I'm going to say that's compression because they're pushing against each other, although she looks like she's doing a better job than him. Looks like a WWE match. Force being used above is, this one is definitely tension. You see how they're like fighting over it? It's pulling away. Good job. All right, now let's move on to 3 types of plate boundaries. You got a whole bunch there. You got convergent plate boundary, transform plate boundary, divergent plate boundary. And then you got other examples of them over there. Good job. Oh, wait a minute. For this part down here, there are blank number of plate boundaries. 3. Okay. Plate boundaries. Convergent plate boundary. 2 plates moving together. Mountain building, trenches, volcanoes. Stress is compression. All right, so right over here is where it says stress, put compression. 2 plates moving together. All right. Subduction zone equals convergent boundary. Oh, we're not onto that one yet, are we? Nope. All right, subduction zone. A subduction zone is a convergent boundary where 2 tectonic plates collide. The Atlantic Ocean is getting larger as the Western Hemisphere, America, moves away from Europe and Asia. The Pacific Ocean, on the other hand, is becoming smaller. So if you look right over here, subduction zone equals convergent boundary where 2 tectonic plates collide or come together. All right. Let's see what it says here. Subduction zones appear as oceanic. Oh, sorry. That one's the next one. Oh, yeah, this one here. Subduction zones appear as deep oceanic trenches. Most of the continental mountain belts occur where plates are pressing against one another. So if you go over here, it says subduction zones appear as oceanic trenches for that. Now over here it says, warning, trenches can cause massive waves and surfers to say, brah, like in this 1-minute video from the trench outside Puerto Rico. This is pretty cool to watch. This is big waves occurring outside of Puerto Rico. Some dudes surfing it, all right? Or dudettes. There's a picture of it right there. Because Puerto Rico, if you look right here, has got this trench right outside. So that, yeah, causes big waves. In the cross-section of the Earth in the southern hemisphere, the map shows a subduction zone that has created the Peru-Chile Trench at the western edge of the South American and Andes Mountains, along the west coast of South America. No notes on this slide. Reason why is because it can be kind of confusing for some people. All right. Next slide. This one right here. So if you look, this is the height of Mount Everest. Mount Everest goes from the, like here, 8,848 meters above sea level. Now look, the Mariana Trench is this gray thing right here. So if you look, it goes down to 11,000 meters. All right. But it also starts at about 4,000 meters. So I'm going to say that the Mariana Trench is not as tall or deep as Everest. So for this over here, according to the picture, which is taller, Mount Everest or the trench? Put Mount Everest. All right. Where two tectonic plates collide. I don't know if I'm going to put that in there. I might actually delete that. All right. I'll actually leave that because you know what? It would help just to know that. All right. Divergent plate boundary. The mid-Atlantic ridge is an example of a blank plate. Let's see over here. Plate tectonics, divergent plate boundaries. Two plates moving apart. Stress equals tension. So, and let's read the next one. Oh, wait. Well, for this one, the mid-Atlantic ridge is an example of a divergent plate boundary. Two plates moving apart for this one. And then stress is tension. Next one is blank crust being formed. Let's see. I think that's going to be for this one, new crust being formed. Earth is producing new crust where two plates are diverging. So this right here, you got a couple of plates, mid-oceanic ridge, oceanic plate, mantle, outer core, inner core. Here we go. In fact, you know what? We're actually going to move this down one. We're going to take a look at this, and we're just going to go like this. I'm going to go Control, cut like that, and hit delete. And then we're going to go down here and go. Good. All right. So we did this already. Mid-Atlantic ridge is an example of divergent plate boundaries. Next slide. Divergent plate boundaries. A satellite view of Africa's Great Rift Valley is caused by two plates pulling apart. Stress equals tension. Divergent plates form new crust. Good. So we got that down there. Good. Transform plate boundaries. Plate boundaries. When two plates slide past one another. Stress equals shearing. This one down here. Transform plate boundaries. When two plates slide past one another. Stress is shearing. All right, let's see what the next slide says. Meeting of the plates. An aerial view shows probably the most familiar meeting of two plates in the United States, the San Andreas Fault in California. This plate boundary, like many transform plate boundaries, cause earthquakes when they slide against each other. So for this one, San Andreas Fault in California causes earthquakes. This one's same image you had before. If the image above was a plate boundary, it would be, for this one, I'm going to say transform plate boundary. If the image above was a plate boundary, it would be convergent because there's two sumos kind of slamming up against each other. If the image above was a plate boundary, it would be divergent because of the tension there. They're pulling it apart. Good job. See what the next slide goes. Why do volcanoes occur? Magma rises to the surface where the Earth's plates pull apart. Divergent zones. Holes in the plates called hot spots. Cooler oceanic crust dives underneath continental crust, convergent boundary, forcing magma to rise to the surface. So if you go over here, occur at plate boundaries, and this one is holes in the plates called hot spots. Convergent plate boundaries, that's just kind of where they occur a lot around which ocean? Now that slide didn't give it to us. Maybe the next will. Where do volcanoes occur? Mostly where plates meet. Middle of tectonic plates at hot spots. A lot of volcanoes occur around the edge of the Pacific Ocean, called the Pacific Ring of Fire. Okay, so it said Pacific Ocean down there. So this one is Pacific. Trench occur blank ocean plates slide under blank continental plates. Let's see what it says for the next slide. Trench forms when the less dense, lighter continental plate overrides the oceanic plate, a subduction forms. I think I'm going to put in there, right? Yeah. All right. So for this one, occurs when the lighter ocean plate slides under heavier continental plates. Divergent, divide. Convergent, collide. Transform, tectonic, slide. Quiz time. Plate boundary where the new crust is being formed. Convergent, divergent, transform. Answers are at the bottom of your plate tectonic notes you are filling in. Two plates sliding next to each other. A, convergent. B, divergent. C, transform. 6. Where mountain building occurs. A, convergent. B, divergent. C, transform. 7. A, shearing. B, tension. C, compression. All the answers for these are in the end of your notes over here. 8. A, shearing. B, tension. C, compression. That's for that right there. 9. Is this shearing? Is this tension? Or is this compression? All right. Subduction occurs at A, transform plate boundary. B, convergent plate boundary. C, divergent plate boundary. Good. And that's the last one. Hey, look, I know this video is like 21 minutes or so. I know you're going to have to rewatch it a few times and pause it and rewind and stuff. Thanks for bearing through it. Hopefully it helps you on out. So thank you very much. Once you're done with this document right here, please share it with me. All right. Thank you. Bye.